Okay, so we're rolling. All right. So for phase shift, let's talk about how all the different things. Let's just review all the different parts of these graphs and how they affect the graph and what they change. All right. So amplitude. What's amplitude do if you change it? How does the graph change? Describe to me the changes. Like if you change the amplitude from 1 to 5, what's it gonna do?
It gets the height gets up.
Yes, it stretches the graph vertically, is what it does. It pulls it up and down in both directions. What if you made it smaller than 1, like a half?
It gets tiny.
It's gonna shrink it. Alright, so it's a vertical stretch or shrink. Just wanna remind you of that, if it's been a while since we talked about it. Alright, so it makes it either really taller or it makes it really smaller, okay? So it's the height of your wave, really. Alright, what about a midline change? From 0. Yeah, so it takes the whole graph and translates it up or down. So it's a vertical shift more so than a stretch or a shrink. Like it's a complete move of every point on the graph moves. Alright, so I would say that's a vertical shift. That's how I classify that. So it's strictly just everything on the graph goes up or down. Okay, so what about, okay, so amplitude, before I say that, amplitude is a vertical thing, midline's a vertical thing. Those are both vertical changes. So when you start talking about period, that's when we're start talking about the horizontal differences. Alright, so if you change the period, okay, if you change it to where B is bigger than 1, what happens when B's bigger than 1? Which way does it go? It shrinks it actually, right? Because B represented the number of complete cycles you would see in that 2 period time frame, so to speak. Alright, so it's gonna horizontally compress it this way. Right? If B is more than 1, like it's a 4x, it shrinks it this way. So I would say that's a compress. And then if B is smaller than 1, but it's not smaller than 0, so it's a fraction like a half or a third or 2/5 or something like that, then that's going to horizontally stretch that. What's another word for a stretch or shrink when it's in the horizontal direction? I know I learned something like that in physical science. Isn't that wavelength basically what that is? Yeah. So that's period. Okay, and then phase shift. Okay. So your amplitude and your period are the stretching factors or shrinking factors. Okay, and midline and phase shift are just your strictly move up, down, left, or right function. So phase shift is a left or right shift. So this is a horizontal shift. The entire graph is scooting left or right. Okay, so that's the differences in what those things do. Okay, so when you're looking at this equation right here, I'm going to ask you to do all the same stuff that we've been doing on the other ones. So we're going to start by defining the amplitude, midline, period, and we are doing phase shifts, so we'll add that to the list. Okay, so I tried to go easy with you, easy on you on these ones that we're doing here at the beginning because it is different than anything you've done yet. So, alright, your amplitude's your A value, so that's still just a 1. Alright, what about midline this time?
Y equals 0.
Yes, Y equals 0. I love that line there. And then a period this time. Okay, so 2 pi over B. What is B?
1.
It is 1. It's your coefficient on your X. Alright, and it is just going to be 2 pi for your period because when you plug in a 1 for B, that's how you're going to get. Alright, now the phase shift. Here we go. Negative C over B is your formula. Alright, so here's the C, and you have to take the sign with it, and then we're going to divide that by whatever the B value was. Alright, so you can either set it up and actually plug it in and think about what the sign changes are going to happen, but I usually usually just say, what's the opposite of that value? That's what I need for C. So even though C is a negative pi, when I plug it in here, what's gonna happen to it? It's gonna be a positive. So it's the opposite of C divided by the B value. So that's pi. Alright, so remind me when we did the other stuff, when we had the graph and then we wrote the equation, what did we say the phase shift, how did you find the phase shift on the graph? What was it?
You just looked at where it started.
Exactly, it's a starting point, alright? So yesterday we made this little list. Where does it start? Where does it end? And then how is the x-axis going to be divided up as far as the tick marks go? We did that yesterday. Okay, so now, where does the graph start? It doesn't start at 0 anymore, does it?
No.
Now it starts at pi. So here's your starting point on the x-axis. This is all about the x-axis right here. Where is it going to end?
2 pi.
Okay, so if it starts at pi, and it's got a period of 2 pi, so here's where we start. This is how far we've got to go. It is going to end at 3 pi. Okay, so we need to make a little note over here about how we did that. We did the start plus the period value. Alright, and you technically are doing that even when it's a 0. Like if this thing started at 0 and the period was 2 pi, where does it end? 2 pi, because 0 plus 2 pi is that. We just didn't do that yesterday because, well, it wasn't necessary, because it's a little bit easier to tell if it's starting at 0 where it's going to stop. Okay, so it starts at pi, it ends at 3 pi because that is a period of 2 pi from start to finish. How's the x-axis going to be incremented? How's it calibrated? We do the period divided by 4 still. So that's 2 pi divided by 4. Well, this is a very familiar division. It's only pi over 2. And that's what we're used to when we do like the parent function. So that's not going to change. All right, talk to me about questions you've got so far. Okay, so can you tell me how this graph is going to look compared to what a regular sine curve would look like? Can you already like visualize where it's going? Okay, if it starts at pi, has it moved left or right? It's moved to the right. Okay, so we're taking that sine curve and like picking it up and moving it to where it starts somewhere else. So when you draw your axes here, you do need a little bit more space on the right than what you're accustomed to because this thing is pushed to the right, okay? I'm going to go ahead, since we're doing pi over 2 for the increments right here, I'm going to go ahead and just start labeling it from 0, but you don't necessarily have to do that always, but since this is the first time I will. Alright, so if we start at 0, this is pi over 2, another pi over 2 would put us at pi, another pi over 2 would put us at 3 pi over 2, oh, this is where we're going to have fun. Alright, we've made it to 2 pi, but remember, we're not stopping there, now we're stopping at 3 pi, so we got to get there. What would this next label be?
5 pi over 2.
It would be, it'd be 5 pi over 2, so add pi over 2 to the 2 pi, that's what you're going to get. All it takes is one more, and you're there, right? You're at 3 pi. Okay, so our graph, now I know it goes on forever in both directions, but we're just going to graph that one little snapshot of what happens from from pi to 3 pi. That's all we want to see. There is more that's happening, but we're just going to graph that one little piece. Y'all got a question so far? You good? Okay. All right, so we have calibrated the axis. We have written our tick marks. We're okay about this part. Okay, now let's go ahead and just do the midline. So it's here at 0. And your amplitude is still 1. We're ready to draw this thing. Okay, so we're doing the sine. Sine starts and ends on the midline. But instead of starting it at 0, now it's got to start at pi. So your first point right here normally would be at 0, but now it's starting at right here. Okay? So where it normally starts, usually starts at 0, but we've pushed everything to the right. So now that's going to be at pi. The next point is where it's going to max out. That's going to hover over 3 pi over 2. Alright, and then the next point's where it comes back and touches the midline, that's at 2 pi now. And then the next point's where we're minimizing a point, I guess. The lowest point. I'm making up words. Alright, and then the last point's where it comes back to the midline again. Alright, so again, I know this is not the whole thing. Technically, it would keep going forever this way, and it go forever this way. Alright, but all I want to do is I just want to see that one little piece of it where the cycle starts at pi and ends at 3 pi. And to me, that's showing me that you knew exactly how, from basing everything from the origin where everything was going. You got a question? You're good? Hannah says she's good. Okay, let's do one more. Y'all wanna do a cosine?
Not particularly.
Not particularly, but you're going to because I'm asking nicely. Okay. Alright, let's see. I don't know if I can do it over here or not. I don't know if I got enough space. Can I erase this? Y'all good? Okay. We're gonna recycle the space here. Well, I should erase that. That's okay. Alright, so we're gonna do a cosine. And see how it feels. Cosine's never fun, but we'll get through it. Alright, so I thought this would be a decent one to try. I'm gonna go ahead and adjust the amplitude this time. Do another little change. We're gonna do a different period change this time. How about we're gonna do, let's do plus this time instead of minus. This may be actually one of the ones you're supposed to do on one of your assignments, but it'll be okay. Alright, so why don't you go ahead and do the details here, get those figured out. And I'm gonna sketch me a graph, or an axis. If you feel good about it, go ahead and try it. But if you don't, that's okay. Alright. So our amplitude is gonna be 2 this time. I almost said 1. It's gonna be 2. Midline is still 0, y'all agree? Alright, and then the period this time, has it changed? No. B is still 1. So we're still gonna just be doing a period of 2 pi. The phase shift this time. Okay, now, let's talk about this because this is the second one that we've done. Do y'all remember when we did the equations from the graphs? We had a little discussion about if B is 1, something's gonna always be true about the phase shift if there is a phase shift. Do you remember that conversation? We kinda like talked about how you could assume or do something and kind of skip a step. So when it comes to the phase shift, if B is 1, then basically all that's happening is that C is going to be the opposite sign of whatever that value is in the parentheses. Remember us talking about that? And I was like, be careful because if B is not 1, you can't just change it and then put it into the equation or whatnot. Same thing applies here. So if B is 1, and you catch that as you're going through here, you can just go ahead and kind of skip this part, knowing that it is just gonna be the opposite of that pi over 2 that's in parentheses. Because that's just how the horizontal shift stuff works with the function. The only reason why we gotta be careful on this one is because, well, we're dealing with a twofold thing. So if B's not 1, then you gotta be careful. But if it is, you can go ahead and just do it like that. Alright? But you can see there that it's gonna work out anyway. Okay, so we're starting now on the other side of the y-axis. We're starting at negative pi over 2. Remember, the phase shift is your start point. Where's it going to end?
3 pi over 2.
Okay, it is going to end at 3 pi over 2. So remember on the other one what we did is we said you take your start point, you add the period length, which is 2 pi, and that's going to tell you where it's going to stop. People usually do not like these problems that end on a fractional piece of pie. That bothers them a little bit, but it's no different in how you handle it, alright? So for your x-axis, our periods was 2 pi again, so when we divide that by 4, we're still gonna have just a pi over 2 as every increment for your x-axis, okay? But this one's kind of weird because we're not pushing it to the right, we're actually pushing everything back on the other side of the axis. So we do need these points over here, but we need one over here, right? Because this thing starts at negative pi over 2. So in the same way that you can start at 0 and add that increment to get these labels, you can start at 0 and subtract that to get the negative labels, okay? I need some WD-40 on that thing, don't they? So we're at negative pi over 2. Alright, so let's add these increments until we get to where it's supposed to stop, okay? So if you add a pi over 2 to a negative pi over 2, you're at 0. That makes me feel good. Alright, then add it again. That's pi over 2. Add it again. You're at pi. Here's where it's going to stop. Alright, so that's all we're going to look at is that little piece. From negative 3 pi over 2 to positive 3 pi over 2. Alright, we're ready to do the midline amplitude. We're almost done. So midline's still at 0. And then, okay, our favorite graph. Cosine. Alright, it does not start on the midline. It starts above it. So instead of having an amplitude of 1, now we need to look at an amplitude of 2, and it's going to start at negative pi over 2. So our curve begins here at 2. Y'all agree? Okay, so we're stretching it vertically. Then the next point is going to be where we're on the midline, and that just so happens to cross at the origin. Then we're going to bottom out down here at pi over 2, and make our way back up to 2 at 3 pi over 2. And if you like to think about it being more continuous, I don't care if you add a little bit more to your graph, but again, all I really care about is that one little snapshot. So how's that? Is that doable? Okay.